Hello, my name is Skylar Kulik. This is my GeoSci 106 video project on the future sustainability of concrete construction, specifically with emphasis on carbon dioxide emissions. The world around us is quite literally built on construction. Constructed facilities compose our homes, centers of commerce, areas of recreation, and so forth. It should be no surprise then that up to 40% of global annual carbon dioxide emissions can be attributed to construction in some way, shape, or form. Constructed materials naturally represent a large portion of this 40% figure. In discussions on green building practices, concrete often takes center stage due to its gargantuan importance and gargantuan emissions. Unique in its ability to be poured in situ into any number of shapes while maintaining immense compressive strength under load after curing, concrete represents a favorite building material for any number of structural applications. However, this comes at a cost. Concrete requires a mixture of aggregates and sand with a binding agent known as cement, which in most modern applications is a very costly Portland cement. Mixing ratios change, but cements typically represent at least 1/6 of any concrete mixture by volume. To produce these cements, first limestone and clays are mined before being ground down and homogenized. This homogenized mixture is then baked in a kiln at 1500 degrees Celsius to produce a material known as clinker. Clinker can then be combined with natural and recycled additives before being ground down into a fine powder for the concrete production and mixing processes. The natural consequence of these production schemes is that traditional Portland cement results in 1 to 2 pounds of carbon dioxide emission for every usable pound of cement produced. This is most wholly attributed to the 1500 degree Celsius heating step, wherein kilns draw a tremendous amount of energy to produce clinker. Globally, the consequence of this is that cements and concrete production processes represent the second largest source of industrial carbon dioxide pollution on the planet. A number of ventures aim to curtail these emissions, however. Since 2018, a company called Carbon Cure has produced equipment that injects carbon dioxide into the traditional concrete mixing process, offsetting overall emissions through the crystallization of carbon dioxide into the final cured concrete product. This uses traditional Portland cement. However, upon mixing of concretes at batch plants, such as the one pictured here, carbon dioxide is injected into the mixture. This carbon dioxide is then trapped and crystallizes, meaning that concrete effectively acts as a carbon sink. Other processes, like a Texas startup called Solidia's proprietary precast construction method, go as far as to adjust the actual chemical composition of traditional Portland cement to enable a 300 degrees Celsius reduction in cement production temperatures. This results in 40% less carbon dioxide emissions. These cement production processes result in lower carbon dioxide emissions, but they also increase the cement and concrete strengths by introducing new chemicals, such as carbon crystals, into the final mixture that increase overall strengths.